Okay. And I guess we'll just, yeah, we're still 3 minutes before the start, so we'll just give some people time
Yes, that's fine.
to join. But yeah, I'm just so excited to have you here, especially like, you know, being at NYU and you're our neighbors up at Columbia. It's exciting for me. You know, I just moved to New York from Pittsburgh, where I was at Carnegie Mellon. So it's exciting for me to start meeting more of my fellow researchers in New York City. And
Actually, I was really, one thing I missed was that I really wanted to come physically there to try
oh yeah, yeah.
collaboration. But well, we'll do whatever we have. But
Well, we would love to have you back once we start doing physical meetings again. We would love to have you back, either for another CUSP talk or just for a more formal talk, or maybe for a talk for one of our research labs.
yeah, no, definitely. And it just would be Nasir Maman is somebody I know pretty well.
Okay.
So he's the, I don't know whether he's still the chair of the computer engineering department or not, but he used to be until last year, I think.
Yeah, I think he is. He's vice dean at Tandon, and actually, I don't know him personally, but it's funny that you brought him up because he actually helped me get my job here. I don't know if he realizes how instrumental he was, but he was a friend of a dean at Carnegie Mellon, and then they introduced me to my current advisor. And so Nasir introduced me to my current advisor. So that was very, very instrumental in my
Okay.
position here.
He's a great guy.
Uh-huh.
Yeah. And he's a good bridge player also.
Bridge, oh my God. I respect anyone who plays bridge. That's my grandmother used to play, and I was always like intimidated because it seemed like a game that was very hard.
Yeah, no,
Yeah.
he's very good at that.
That's nice. Well, maybe I should learn bridge now that I'm, you know, I do machine learning. I think I can handle bridge now, maybe. Maybe when I was a child, it seemed intimidating, but maybe I should get over my intimidation now.
So you can create unlike Deep Blue, you can say Deep Bridge.
Yeah.
That's an interesting one.
Oh, it's still, we just hit 12 and we already have 12 participants. So we'll wait like a few more minutes.
That's fine.
Looks like we're going to have a good turnout.
Good.
So Dr. Dalal, I made you a co-host. So just in case for some reason my connection gets dropped, which it shouldn't, but in case it does, that you'll still be host. But
And you
yeah,
have my phone number also in case if you run into trouble.
yeah, I do. And I'll text you right now my phone number so you have that.
Okay. Thank you.
Hello, Siddhartha.
Hey, Juret, how are you doing?
Good to see you. Thank you so much for giving the talk. I'm really looking forward to it.
Well, it's my pleasure. Indeed, I wish I could have been there in person, as I was mentioning to Jackie. But,
Of course, yeah. No, I think we're all itching to go back to that. But you know, soon enough, we'll have a chance.
no, actually, at Columbia, we have already. I'm meeting every day with students and faculty, other faculty, and so on. As long as we are all vaccinated and we are wearing a mask, it's okay to go there. So it's been okay so far.
That's great. That's good. Right. I think Jackie already mentioned that we'll wait just a second.
Yeah, we'll wait a few more minutes.
Yeah.
Sid, are you continuing to work in this area, and how's Coinbase doing?
I think the whole crypto market has gone crazy. Am I right or
It
wrong?
has.
But I'm actually doing a lot of interesting stuff, and I've been working on an interesting DApp, which I've been working on, which is called Collaborative Prediction Market. One of these days, I'd love to talk with you all, because all my collaboration and related things started at Rand Corporation. Mm,
Sid, if we can make some money out of it, give us the tips, okay, ahead of time.
Well, I don't know, but anyway, we'll see how it goes.
Thanks.
We'll see.
I should tell you guys, Sid has worked with, he worked with Paul Horn a lot when Paul was putting together this CUSP thing. Sid was running a whole operation at AIG that was trying to support some projects at CUSP. He did a really good job. And then,
Oh, very cool.
and then Sid's been everywhere. He's been at AT&T, Bell Labs. He's been at Rand. I mean, and now he's still bloody working at Columbia.
Wonderful. Yeah, I do hope we get back to in-person meetings soon. I know that within NYU, we're doing a lot more in-person meetings, but it's still hard to have people come from outside NYU because of like the clearance issues. Like, it's very hard to have visitors come onto campus because of like, all the vaccine checks and everything like that.
You're right. You're right.
How does Columbia do it, Sid? What protocols do you use?
Well, I'm teaching in person. I'm meeting my research students in meetings. Only thing is we all have to be vaccinated. We have to certify every day that I don't have any symptoms of COVID. And on top of it, we all wear a mask when we are indoor and can't have a social distancing. So all three are there, and things seems to be going fine. A lot better. Let me put that. Not fine, but at least a lot better than what it was. So this semester has been very productive. Last year was not.
Disaster.
It was okay. Last year.
Juan, are you at home or you're in the office today? Can't tell.
I'm at home today. Actually, yes. I'm at home today.
Okay, well, maybe we should, wow, we already have 27 participants. That's great. Maybe we should get started with intros, with an introduction. What do you think, Juan, or should we wait a little longer?
I think we should go ahead.
Okay. So I'm very honored to introduce you to Dr. Siddhartha Dalal. He goes by Sid as well, Sid Dalal. So a little bit of history. He started his career at Bell Labs and Bell Corp, where he was chief scientist and executive director. After Bell Labs, he went on to become CTO at Rand Corporation. And then he also went on to become VP of research at Xerox. And from there, he became chief data scientist and senior vice president at AIG. AIG is American International Group, which is a multinational finance and insurance corporation. At AIG, he was in charge of R&D, and this included the creation and application of many tools from computer vision to AI to NLP to Internet of Things for managing risks. He is now a professor of practice at Columbia University with joint appointments in the Applied Analytics program and the Statistics department. His research is in blockchain, cryptocurrencies, as well as machine learning, and he also teaches in these areas. He is a member of the Army Science Board, which is appointed by the Secretary of Defense to advise the Army on technologies. And he also has several awards, including those from IEEE, ASA, and ASQ. He has over 100 peer-reviewed publications, patents, and monographs covering the areas of risk analysis, medical informatics, Bayesian statistics, economics, image processing, and sensor networks. And so with that, I would like to give it away to Dr. Dalal for this great presentation.
Thank you so much, Jackie, and all of you at NYU to invite me. And it's just my pleasure. I used to, while I was at AIG, I worked very closely with Paul Horn and Yuri here, who is here. And also I work very closely with Nasir Moiman and variety of people across NYU. So I want to tell you that I have been very pleased, and I'm very pleased right now to be here. And just to start off a little bit. So I have been involved in all kinds of activities. This is one of the projects which has been rather challenging, to be honest, especially because of data and data collection and all the protocols and cleaning of the data and everything else. The total data which was collected was more like 6 gigabytes of data. And that was all very, very complex. So I'll tell you a little bit about it. The challenges were, I was hoping that this would be a 6-month project, and it continued for 2 years. So I give you a little bit of background about this. So as you know, ransomware has become a very big deal. And I've been very intrigued by trying to see to what extent can we identify people who are involved with ransomware, and to what extent, if we can identify at least in some fashion, and in that particular case, more things can be done, and we can understand a variety of other things related to that. So just a little bit of press headline: ransomware takes on urgency ahead of vote, which was passed in the Congress. And there are several recent attacks, including Colonial Pipeline, which were concerns about that the country may freeze, and JBS about the food and food supplies. And every day, those are continuing. The major attack this year so far has been more than 2,000 major incidents. We're not talking about 3 Bitcoins and 2 Bitcoin kind of questions. Well, though there are many of those which are like 1 and 2 Bitcoin, give 2 Bitcoin and we'll do something. And actually, there is a whole website which is taking into account list and alerts which have been issued about ransomware. So you might want to take a look at it. What is ransomware? I think most of you know, but to the extent that you may not know, then I'll just quickly define. So cyber criminal, usually we were always concerned about that people will break in and then steal all the data. Now cyber criminals found that to be very complex, and they had to get the data, they were likely to be caught up and everything else. So the idea was very, very simple, that you give a malicious software, a malware of some sort, to block people or organizations from accessing their own data and their own computer systems until a ransom has been paid. And the way the ransom is paid typically and mostly is in cryptocurrencies such as Bitcoin. And it is easier for bad actors to receive payment without exposing their identities. Bitcoin actually accounted for 98% of ransomware payment made in the first quarter of 2019. And in fact, JBS as well as the Colonial Pipeline paid ransom in Bitcoin. And between 2012 and 17 alone, conservative losses in Bitcoin, just I'm talking about just 5 years, and this is before all of this became very, very big, the numbers which have been quoted roughly turns out to be close to, at today's price of around $63,000, $64,000 of Bitcoin, is around more than $1.5 billion. So the question really I started wondering was, can we detect bad actors, and can we in some fashion at least detect them and identify in some fashion? So what kind of malware are used for ransomware? There are a number of different kinds. One of them is screenware. It locks up all the screens and you can't go below that. There are other encryption kind of thing, and many of them are well known now in hindsight. And they were all related to the vulnerability in operating system or social phishing and other kind of attacks. The encryptions were like WannaCry, which was actually created by NSA and stolen and distributed. This was on the vulnerability of Microsoft Windows. And it was fixed, but many people did not put a patch. Consequently, thousands and thousands, hundreds of thousands of computers across the world were affected by this. And then there are many other recent ones. I won't go into all of this detail, but if you want to take a look at it, you can take a look at variety of things on Reddit, Bitcoin abuse, and variety of other sources. You can take a look at it. Reddit is a good source for many of these things to look at, and Bitcoin abuse is another good source. So you might want to take a look at in terms of what actually is going on in that world here itself. So let me just quickly describe, to the extent that you may not know blockchain. Blockchain were invented by actually at Balcor, where I was with my colleagues. My colleagues invented it, Stu Haber and Scott Stornetta. And they were thinking about a completely different strategy, application. They were thinking of digital rights management in terms of legal stuff. And they started a company which was spun out of Balcor called Surety Corporation. And Surety Corporation didn't become successful. It had other problems. So it finally did not go anywhere. But this was picked up by Satoshi Nakamoto, and he created a Bitcoin. One of the major angle of this Bitcoin was blockchain. So blockchain is very, very simple, that it basically has got, if you want to call this is nothing but a list, which will be such a way that you will create a certain number of transactions within a block, and those transactions will refer to a previous block, which will be hash of a previous block, and hash of a previous block, and hash of a previous block. And so the idea was that this transaction, therefore, will become immutable. Because if you change anywhere, somewhere, tamper anywhere else, then the hash will change. And the kind of hash which is being used is nothing but cryptographic hash. And the one which is mainly used in Bitcoin is SHA-256. But there are other versions of that, RIP-160 and other kind of things are being used also. And here is a sort of then of course you have got private key and public key to identify and to do transactions. And these transactions are done by, in terms of account based, rather, it's done by transaction based rather than account based. So it doesn't maintain balance of everything. It just, for any account holder, it just basically refers, whenever you want to do transaction, you will have to specify where the money came from, and you will have to specify the transaction from which the money came from, and miners, which we won't go into the detail, miners will go and try to verify the transaction, that that money was unspent, and they would check all the blocks in between to make sure that it was not, there was no double spend. That's a big deal in terms of double spending itself. And Bitcoin store, the core starts from Genesis block, and there are close to around 800 million transactions so far right now. Much of this data, of course, all of this data is in terms of binary form, so it's not human readable. So we use actually a parser, which came from Princeton, called BlockSci, and it makes it human readable on a scale. Otherwise, we would have some difficulty with that. So I just wanted to point out, here is a transaction. You will have to specify which public key it will go to, and you will have to sign where it came from. So you'll have to sign that, oh, I had a transaction earlier here. It is a signature, which is based on your private key. Of course, you never show your private key to anyone, but you are just showing signature. And then ultimately there is a value, how many Bitcoins are being transferred and so on. So Bitcoin is basically used only for currency exchanges. Now, the Ethereum and other networks are very different, and I've been greatly involved with some of the Ethereum related work also, but I won't talk about it today. So let me continue a little bit about the Bitcoin here itself. So what are the key features of Bitcoins? Right? There is a finite supply, which is 21 million Bitcoin, is ever it can be. And every time somebody mines a block, then they get 6.25 Bitcoin. A miner who is successful will get a 6.25 Bitcoin. I won't go into the detail about mining and all the challenges related to puzzles and difficulties and so on and so forth. But I think just wanted to mention, the key part, as I mentioned to you in the previous diagram, is that all transactions become immutable. So once you give somebody money, and it has gone, some number of blocks have passed since then in that case, nobody can ever take away your money. So if you cannot go back. So if you have paid money to a ransomware actor, you cannot go back to and say, now I don't want to give money. I can't cancel my transaction. That's one of the great things for ransomware actors, that they don't, they're guaranteed one certain number of blocks passes, then they're guaranteed to have that. And the second one, which is a critical part, is that user can have as many accounts as one wants. So I can have 100,000 accounts if I want. They're all basically 256-bit addresses. Actually, it's 160 bits if we do RIPE MD, but I won't go into the detail. But in effect, the address space is so big, it's bigger than number of atoms in the world. So you can have as many as you want. If you want 1 billion, not a problem. If you want trillion, that's not a problem. So, and it consequently, you have a pseudo-anonymity, which is a big challenge. So that I can get money in one of my account, and then I can transfer to another account, and nobody will know who it is. And I never have to divulge my identity. So I don't have to have this whole notion which banks require, KYC, know your customers, is not required at all in any of these things, unless you go through regular exchanges like Coinbase or other kind of things. But most of the exchanges which are which are there, most of them won't require any of those things. So that's what it is. And then you can go on changing address, which is sort of another thing which you are always recommended. So remember, this is a transaction base. So if it is a transaction base, means you have to, whatever money you're taking out from a previous transaction, all money has to be spent. All that money has to be spent. So you can either go back to your previous address and say, okay, fine, I have to give 5 to Yuri, and I have got total 8. I'm giving 5 to Yuri, so I got these 3, so that can go to my regular address, or I'll create a new address, and that's called change of address. So I can go on changing the addresses constantly, and so it makes it tracking extraordinarily hard, and the complexity of calculations can be very intense. And some of the calculations on the supercluster at Columbia took more than 10 days, and we ran out of time after 10 days when the people who are running the cluster kicked us out. So just to let you know, the 10, 12 days were very feasible. Let me continue here. If you have any question, just ask me. I'm just first going to introduce you, then I'll talk a little bit about what actually was the protocol and algorithms which were used for collecting the data. And then I will talk about some sort of data analysis to figure out what to do with it. Because ultimately, if you want to think about it, blockchain is nothing but all these transactions are connected. So if you want to think about it, it's a big network. It's a big graph. It's such a big graph. You can have a huge number of nodes and of course edges, and edges are far more. So you can imagine that what can go wrong. So these are all very, very big graphs here itself. And so we are trying to do machine learning on graphs ultimately. And then we are trying to identify things. So there are all kinds of complexity which I will talk about, and not necessarily going into very deep technical details of everything here. And just quickly, some of the Bitcoin statistics, number of transactions. This is something I saw it, I think, in 2019. So you can see how many transactions and so on and so forth. More interestingly, actually, that there is a hypothesis by the people here below that the price of Bitcoin is related to ransomware attacks. The more there are attacks, the more price goes up. So it's sort of an interesting one. Now, it's hard to believe because this could be coincidence. This is what we call as spurious correlation. It's possible. But I just want to tell you that there is a theory that whenever there is an attack, after that it goes up and then it again cools down and so on. So they have analyzed a number of different sets of data. And if you look at their data collection, then you tend to see that locally, at least, that once the attack has been created and it becomes well known, not to one company, but many places, then in that particular case, the price seems to be going up. Now, obviously, you can question it, and I'm not going to argue whether it's correct or not because I just don't know enough about it. It's very hard to, it could be just purely spurious, but there is a theory that more, and that really could be pretty bad, correct? Because if you think that you want to increase the price of Bitcoin, you might as well do ransomware attacks. So, this is not necessarily good. If this is true, it just would be terrible. But you can see variety of coincidences of that type.
Wait, can I ask one question?
Yeah, please.
Sorry.
Oh,
So-
just I want to tell you just 1 second, Jackie. Any of you, you are more than welcome to stop me anytime. I don't want this to be monologue. I want this to be dialogue. And in fact, if you're interested further, I'll be delighted to talk with you. And in fact, including potential research collaboration. So please go ahead. Go ahead, Jackie.
That's wonderful. I was just curious if you, with this, was it this graph or the one before that you were just showing where when there's an attack, the price goes up? Okay, so I understand like why that would be why a ransomware actor that might inspire them to attack, but why would the price go up of the Bitcoin because of an attack? Is it because the Bitcoin is less attractive now because of the attack? Is that the idea?
So, Jackie, it's very hard to say. It's like, there are people who say Tuesday morning, if it rains, then team A will win. So, it's like that. But there is a reason. Let me tell you a little bit of reason. Because then people are assured that there is a anonymity and pseudo-anonymity. So they might even feel more confidence that even FBI or any of them cannot track me on any of these transactions. They do track, but not using Bitcoin transaction data. They do track by checking your IP address or variety of other means. Or they might have some private information that somebody might have bragged something about that I did get this money, and then somebody informed somebody. But actually, if you look at it, the Bitcoin network, if you go in, it's all addresses are all and transactions are all publicly available. You can look at every possible transaction, but you cannot. They're all you cannot necessarily connect them to the user. Not necessarily.
Okay, so that makes sense. So the theory is that it's going to get more attractive because people. Okay, yeah, I get it. Sorry, David, did I interrupt you?
Oh no, not at all. I interrupted you by mistake. Sorry. So Sid, I mean, one interesting empirical test might be to control for general order flow. So if there are inflows into Bitcoin that are unrelated to the ransomware attack, and you account for those, and you still see this, then it's evidence that ransomware attacks are contributing to the value. If in fact order inflow, right, subsumes the ransomware attack, then that's evidence that perhaps it's not specific to the ransomware attack.
Well,
that might be an interesting empirical test, right?
David, thank you so much. Oh, thank you for coming. I'm glad to see you.
Well, it's been too long. It's good to see you. I'll try to reach out afterwards in the next couple of weeks and get caught up.
Yeah, we should have a dialogue about this part. I don't want to.
Let's go offline for that. I had one other question. Have you looked at, so in 2016, Ethereum had an issue where they had to unwind some of their block.
Yes.
And it demonstrated publicly to the world that the immutability is dependent on certain conditions for the various blockchain implementations. Have you looked much into the places where the immutability doesn't bind?
I know a bit about it, so I don't want to tell you I'm an expert on it. There was a hard fork, and it became two Ether. One was called Classic Ether, and the other one was a regular Ether. Okay, so that hard fork still has continued in some fashion. So just to let you know that. Now there are people. This is the now matter of deciding at some point. You're not really doing anything other than at some point you will say, before this block, all transactions are valid. After this block, I will have a hard fork. I will have a different blockchain coming along. So that's the way it was done. It was not trying. They were, in fact, even if they could identify, they could not do much with it. But they just decided that certain number of blocks will be beyond that. They will change it, and it was a matter of within a day or two, which is when Vitalik and his compatriot decided that. So we will go into that some other time. But
Oh,
there
yeah,
are
thank you for the clarification. Yeah.
there are even hard forks in Bitcoin also. There are a number of hard forks in Bitcoin, and I won't go into the detail of hard fork and soft fork and other kind of things.
So in some sense, and then I'm gonna be quiet, but what they
No,
effectively
you don't
did
need
was
to
sort
be
of,
quiet. I didn't
yeah,
mean to say that.
they
So,
sort of overwrote and said, okay, here's the valid path going forward. We're going to ignore the
Yeah.
place where there was the issue.
yeah, that's what they
Thank
did.
you. Yeah.
That's and there has been a lot of concern about it, and in fact, a lot of people got very upset about it, saying that this is supposed to be never to be done, and so anyway, that was this whole big deal. But I won't go into the details today about it. But if you want, I'll be happy to tell you about it more. Okay, let me continue here. So bad actors. So what kind of bad actors are there? So we have been thinking a little bit about three kinds of actors, and we have actually done some work on the three kinds of actor. But I'm going to report only on two kinds of actor today. So first one is that we wanted to have different categories, including ransomware scammers. So people usually, many of the people, once they have paid ransomware attack and they do things, clean up at their act, then afterwards they tend to publish that here is the address which ransomware has asked for to me. So there is a whole number of websites which are really collecting all that kind of data, whether it's on Reddit or it's on Bitcoin abuse or a variety of other things. So that's one part. The other one is a gambler. So remember, a lot of gambling is also for not necessarily all the time about ransomware, but it has to do with, in some fashion, turning the money into a different set of money. So you can go to for example, just go to a particular gambling house and you give some amount of cash and they'll give you a certain amount of chips. And then afterwards, you do a variety of things. You may lose a little bit of money. You may go back and give chips back and you will get cash. Now you're a completely different identity. So it is being used for basically flushing money or turning money and so on. So we were interested in gamblers also. And not gambling houses, but gamblers. And gambling houses are known. So we looked at the people who were doing gambling and tried to see what was going on with those people. So that was the second one. And the third one, of course, many of you know already about the dark web. So many of them are coming from Tor. And what can you do with the Tor addresses? Because Tor routers are going all across in random fashion. And so what can we do? So those are the three things we were interested in. We have done some analysis with Tor, but I'm not going to talk about today Tor at all. But just to let you know that these are the three places we thought would be interesting, that we can collect some real data and we can do something with. So I just wanted to mention that to you. So we basically looked at data up to July 2019 with around 400 million transactions and 40 million addresses. And we basically, for ransomware, we looked at the data coming from Bitcoin Who is Who, Bitcoin Abuse, SEC Action, and previous literature, as well as from Reddit. So these are the places where people had reported that here was a ransomware account. Here is the address of this account, and so on. For gambling, what we did was there is this Wallet Explorer site has got all sites which are related to gambling. And so if you look at people who are going to gambling, so you don't look at gambling houses, but people who are sending money to gambling houses or getting money from gambling houses, we looked at some of those as a part of it. And then the third one was we selected certain random number of addresses which were coming out from another site itself. So here is an example here is one example. I think this was coming from Bitcoin Abuse, the January 4, 2019, and the blackmailer with this wallet where he uses this thing for transferring Bitcoins and so on and so forth. Now, there is always some risk that, it may be not correct. So I want to accept that risk, but usually these are being checked by Bitcoin abuse and other kind of things. But it's conceivable that somebody may falsely accuse one particular address to be ransomware. So I want to acknowledge that. But with that proviso and with that limitation, I'm going to continue here. So let me continue. So now what do we do? So as I mentioned to you, the Bitcoin is, if you look at all the Bitcoin transactions, it's nothing but a big graph, starting from Genesis block, which is where Satoshi Nakamoto started originally, and then continuing on block after block, and within each block, you can have up to around 2,000 to 3,000 transactions. Now, there are more fancy ways of doing it, which I won't go into detail, called sharding and lightning network, but I won't go into the details of that kind of thing. But so roughly around 2,000 transactions can be in a block. And just for our knowledge, quickly, a block is approximately every 10 minutes. And so per day, there are 144 blocks. So 60 times 24, 6 times 24 would be 144 blocks a day. So how do we collect the data? So what we have is a transaction graph. Transaction graph is what? So it has got a transaction. So here is, for example, one of the transaction within this block, within this transaction. And this transaction might have a lot of input addresses and some number of output addresses. Now this output, of course, is not spent yet unless somebody calls it in the future, in the next transaction here, and say refers to this transaction. Then that money goes here and that would be paid out to somebody else. So this is where the signature comes in and other kind of things. If I want to send it, and when I send it to someone, I have to give some sort of script to allow somebody to ultimately claim it. And so these are the different kind of transaction. And then a block has got multiple transactions of various types. And now you can imagine that this transaction may be coming from here, and there is a chance that this transaction here may actually have money coming from elsewhere also. So within a transaction, you can have multiple inputs. So I may not have enough money in one account. I may decide to have I have a 5 Bitcoin here and 3 Bitcoin there, and I need 7 Bitcoin. Then I might pull 5 and 3 together. And so I can go back and forth. So this is not, so I can have multiple transactions coming to same transaction and so on. So just a little bit more complex that you can have. So you can imagine a node, and so a node can have multiple incoming edges and multiple outgoing edges. So just remember that.
But Sid, this is Yuri. If you don't mind, it's a dumb question, but I have an address.
There's a dumb question from you, Yuri. Please.
Trust me, this one is. I have an address, and I send somebody else that address. Once I've sent that address, does that mean that that person has the value of the Bitcoin after the hash has been created?
Hold on 1 second. Let me make sure. You send money. So somebody gives you an address and say that, okay, send me money to this. Okay, then you can send the money.
Right.
And perfectly fine. You will have to specify how much money you want to spend. So
Right.
these edges are all weighted edges by the amount of money which is being used. So this is a weighted DAG, directed acyclic graph. So this is not, say, a cycle, because always transactions are moving in time. So that's the way the whole thing works. Is that, am I answering your question or not? I'm not sure.
Not really. I don't know.
Explain to me if I may, or if you.
Yeah, I'll send you an email. Thanks.
Okay, fine. We can talk on the phone also afterwards.
Very good. Thanks.
I can hang around after the thing is done, if Jackie allows me to.
Very good.
I'll leave that to you. Okay, let me continue here. So you can see that how this graph is, and so we decided to create this create this algorithm for weighted transaction graph, where we had to have weights which were nothing but amount of.
Sorry, I realized I was muted. I said, sure, it's totally fine for us to hang around afterwards. That's no problem at all.
Thank you so much.
Okay.
So quickly, let me move quickly because I might run out of time. So I want to get to the bottom of this thing. So, so what we really needed to do was, if I wanted to track a particular Bitcoin ransomware actor meaning the address, sorry, let me put that way, address. So we specified 2 different things. So a blockchain Bitcoin ransomware person is an address. which is specifically used for ransomware collection. But actor can have many addresses. So we really need to go. So even if you specify this is the address, doesn't mean anything, because they can have many, many, many pseudonames, pseudo addresses. So you have to really think about ultimately able to get to the multiple addresses in some fashion. So that's why the whole analysis comes out to be complicated, because you need to cluster many different kind of addresses, and you need to create algorithms for constructing clusters of addresses which would define one particular actor. So an actor can have many, many addresses, and ultimately we want to find an actor, and we want to see their graph, and we want to be able to then do some sort of machine learning to predict which is likely to be ransomware actor, which is likely to be random, which is likely to be gambling kind of thing, and so on and so forth. That's what we are trying to do. So now we need to really, first of all, create this transaction graph. From this transaction graph, so this transaction graph, what we do is typically we'll start with one particular actor, one particular address, which has been reported as ransomware. Then what we do is we track it down to which transaction it was shown first time. And then we track it down where the money came for that particular address. And then this may have money coming down from other addresses. This may also have money coming out from other addresses. So we track them down constantly. And then they may be connected to, somebody else might be connected to this address, and somebody else might be connected to this address. And then they might be connected here also. So all of these things had to be taken into account. So you can imagine that a transaction the graph becomes huge. It's every possible combination you can think about, going backward and forward, is what we need to do. Now, one of the hypotheses which we made, which is sort of, I think people would accept it, that once ransomware actors are there, and then they are likely to move money very, very fast. And they're not going to be around for too long. They want to take out the money as soon as possible and move on in some fashion. So what we decided that we were going to do all this tracking across both sides of it, past and their connection, and future and their connection, and so on. So we decided that anytime we find a particular block where a particular one address of that actor was involved, we would just look at plus or minus 1 day. And then we would look at basically create a graph around that plus or minus 1 day, all the transactions. So this is just a transaction graph. But the transaction starts at the first time we see that particular actor here itself. And then we compute how much money is being transferred, and so on and so forth. So we create weighted graphs of various types here. So we continue to termination. So this is the way we created graph here itself. And then we had to have exceptions of various types. Some of this is probably too much minutia of detail, so I apologize, but it turns out that without doing all of this, you just nothing works. So we had to deal with all this minutia. So if the money was going to exchanges or gambling houses, we said that we stop there, because it's like if you give money to bank and then bank gives some money to somewhere else, then it could be completely unrelated person. So you want to stop there. So if money was going out to gambling houses or exchanges, we automatically stopped everything. We had to also tax some special kind of transaction, which I'll go into the detail very, very quickly here itself.
Can I ask a quick question?
Just one second. I just want to show you. So here is one actor whose address was this, and this is nothing but around 1,000 transactions around it. And if you look at it, there are arrows and everything else. So this is nothing but directed acyclic graph of the transaction done by this person within around 1,000 transactions around it. Go ahead. Now, there was a question, so I'm happy to answer it. Go ahead. Sorry, somebody said that there was a question.
It was Richard Pavlik.
Okay, shall I go further or shall I wait? Wasn't there a question?
There it is. I'm sorry, it went away. I got the screen back. I just wanted to ask how you associated the many addresses to an actor in the first place so that you can conduct the analysis on that actor.
So that's the next thing. So first one, we had to find one address. of that, and then we had to find and get all other addresses of that person to the extent we can. And so I want to tell you that a lot of it is based on heuristical algorithms. There is no guaranteed proof of this, but there is heuristic algorithms, and then we check whether to what extent this heuristic algorithm have stood in terms of what others have done. So that's the way it has been done. So I just want to tell you, so now we go to, given one actor's address, we create this transaction graph around, and we are assuming that they will be moving money very, very fast. So there would be many multiple addresses of this person, and we would be able to find it by some sort of algorithm. So here is a, so if you want, you can create address to address graph, but address to address graph has no meaning, as you just mentioned, because ultimately you can have many, many addresses. So you want to really find actor to actor graph, not address to address graph. The address to address graph doesn't have much of meaning, although you might have to construct it to create address to address to actor graph. So that's but that's not the important one. Address to address graph is not the important one. So if you want to think about it, address to address graph is of course a dual of transaction graph, where edges become vertices and vertices become edges of various types. There are certain kind of transaction we had to deal in spatial detail. One is called coin-based transaction, which is nothing but money given to the miners. As soon as they block, they create a block because there is no past money coming from anywhere else. There is a whole change of address, and how do we identify change of address? There is something called proof of burn, where an address may burn a Bitcoin to save a data item on the blockchain. Now that's not very common anymore, but it used to be very, very common because it was a cheap way to save data, which was some sort of, again, hash function. Some sort of hash would be saved on your blockchain, and you can show it to people that this is my hash. So this was used for a variety of other reasons.
So, sorry, what does to burn a coin mean?
Burn means that you send money, and there is a special tag on it, and this money, the output address is not a valid address. So you don't have to have valid address. It doesn't go anywhere else, but there is some sort of data which is part of it, and data gets stored on blockchain.
So the value just disappears?
It disappears because it's never going to be claimed by anyone. It's never going to be claimed by anyone. That's called burn. So there is a special tag for it, which is created in one of the forks, which is called proof of burn. So that miners don't even have to think about or track that this was unspent transaction. So that's called, so people do burn, people used to burn money. Even now they burn money, but very little. It's like maybe 1 Satoshi. 1 Bitcoin is a 10 to the power 8 Satoshi. So it's around 100 million Satoshis is in 1 Bitcoin. So just to be aware of it. There are some non-standard scripts, which I won't go into the detail, but we had to deal with it. And then there are special transactions, which are really very difficult because those are transactions where multiple people want to lose their identity. So what they would do is they would have a third party, and this third party, what they would do is they would send, this third party would agree that here are 4 people who want to change money and they don't want to be tracked. So what they would do is they will find another set of 4 addresses, and transaction will be such a way that money can go from any of this to any of this here. So that's called coin join transaction. Now coin join transaction has become a big deal because you can easily lose identity of anyone if it is a coin join transaction, and it becomes really painful. I won't have time enough to go into the details of coin join transaction, but there are commercial services available right now which are able to do these coin join transactions. So if you want to lose in some fashion that your identity and that nobody can track it, then you make it so hard that number of possible combinations may become million combinations. There might be 100 people on one side and 100 people on the other side. Only you know that some money has been transferred, and you know each of them how much they got, but it's not saying who gets whom from what. That's not being said in any of transactions. There are set of transactions. So consequently, it's easy to lose people. So this is one of the big issue and big challenges in terms of coin join transactions. The coin join and change of address transactions are the tough one. Now let me quickly mention global algorithm for clustering. I think there was this question about how do you go from address to all the addresses given to a block. So what we do is, if true addresses are inputs to the same transaction, this is sort of commonly taken as a gospel, but it is a heuristic still. So there are challenges and there is not 100% correct, but there are heuristics here. See, multiple addresses are going in the same transaction. That means chances are high that one person is controlling all of those addresses. So this is one particular transaction algorithm is being used. The other one algorithm which is being, so if you have 4 addresses, and so which are inputting 5 Bitcoin here, 3 Bitcoin here, 2 Bitcoin here, chances are high that the same person is doing it. So chances are that it will be same actor. Now, the second one is if there is a change of address, a new address has been created on fly, then in that particular case, if there is only one such thing, then chances are high that that would be related to the person who is inputting the Bitcoin. So this is a sort of clustering algorithm, but this doesn't work very well if you go across the whole blockchain. In fact, one of the big cluster had 60 million addresses. And in fact, in one of our implementation, 98% of addresses belong to one cluster, means one actor. That's just not feasible, correct? So there, each of them has some error chance. And then when you try to combine all these things, then the error just blows up exponentially. And consequently, you really get not very good results. So what we decided was very simple idea, was that we don't want to do clustering across the whole Bitcoin blockchain. We want to look at within plus or minus 1 day only. So there are 2 advantages of it, that it could computationally, of course, easy, but more importantly, that if we made an error in any of one graph, it won't affect the other graphs. So what we did was we went to a particular actor within plus or minus 1 day, we look at all transactions, and then we just also do clustering only within that plus or minus 1 day rather than across the whole chain. So there is a chance that we will lose some of the addresses, but if people are moving, as I mentioned to you, the whole issue, ransomware actors are moving very, very fast their money because they don't want to be caught too long and they don't want people to track them down often. So they will go on moving the money there fast. Therefore, consequently, this seems to be a reasonable one. And the great advantage of that was that we were able to have a meaningful cluster of various sizes. So just to let you know. I won't go into the detail. There are a lot of issues related to coin join and local cluster and so on. I won't go into the details of the algorithms of various types. Now, let's go to the real stuff now. Given all this data cleaning, it took almost a year, to be honest. So it wasn't very trivial because every time we would do it and then we would make somewhere along things would fail and we would have to go back and we would have to think about what went wrong, what kind of algorithms was heuristics was not right, and so on and so forth. So it took a long time. So so that was one of the big issues here. Then what we did is now for each of the address, we got a corresponding actor based on this clustering idea, which I just mentioned. And we looked at within plus or minus 1 day, which is plus or minus 144 blocks. So you had 288 blocks of data. And some of the data, as I mentioned to you, a transaction can have 100 inputs, 100 addresses coming in and 200 addresses going out. So it could be still huge. It could be more than 1 million addresses within one graph. It's very, very feasible. And so we had a computational limit. We couldn't go beyond 1 million addresses in a given graph. And so that there were some minor complications, but not too many of those. So we had to handle that. Then what we did was now we needed to learn something about these graphs and we needed to do machine learning of some sort. So we looked at a variety of features, which are centrality parameters of various types, which are nothing but degree, closeness, betweenness, PageRank is the one which is you call Google rank also, which is nothing but reputation, which is nothing but how many inputs you are getting. And ransomware actors are likely to get more inputs, and so consequently they're likely to have a higher PageRank. Neighborhood size, coreness is nothing but measuring how many degrees you have at your core, and that sort of defines your centrality, where you are in the center of the graph or not. And there is a cluster coefficient, which are measuring how much is the interaction amongst the neighbors. If the interactions amongst the neighbor is low, then in that particular case, the neighbors don't seem to know each other well. And consequently, they're different, they're likely to be less for ransomware actor and so on, because they might be dealing with independent attacks on independent people. So that those are the kind of things. I will quickly talk a little bit about the variety of data analysis. I think this is a paper which is now just appeared in one of the conferences, and it's already on RxIV. So you can actually take a look at the more details if you want to take a look at more details. But here are like number of vertices here of graphs. What we did was we separated our graph in terms of what are known as two kinds of graph for each of them. One of them is simple graph, which means that you remove all the loops and all the multiplicity of edges. And then the second type of thing which we did was we looked at ego graph. So given a cluster, given a particular actor, we looked at only within one step, 2 steps, or 3 steps, and interactions between all of those. These are called ego graphs, ego 1, ego 2, ego 3. It's slightly different than graph motifs, which you might have heard about. So, so that's the way we did it. So I just want to mention that there were several such kind of things which we looked at. So there were hundreds of such kind of graphs we looked at. And here is one example that if you look at ransomware label, the number of vertices are very big. So they were happening in terms of more people were sending money to them and everything else. And the number of vertices were much larger who were connected to them. And here nothing but number of edges. If you look at PageRank, if you remember, PageRank is nothing but telling you how many inputs are coming to you. More inputs you have, more reputation you have. This is what comes from Google rank, correct? Google idea of PageRank. So if you look at it, a lot of people are sending money to ransomware actors, but they're not getting money back here. So their rank is likely to be higher than any of the other people. The more interesting thing was that gambling people also tend not to get a lot of money to them. They were just sending out money to gambling houses and so on. So their page rank is low. So you can see a variety of things and closeness and other kind of things. I can go on plotting, but in view of time, I won't go into all the details related to that. The more important thing is the features we looked at were really discriminating in some fashion between these 3 classes we talked about: ransomware, random, and gamblers. Those were 3 classes we were able to see that they were differentiating. We tried to look at the corresponding CNN kind of approaches, but CNN kind of approaches would require each graph to have same number of nodes, which is not the case here, because every time there is a graph, it would have different sets of nodes. So the standard CNN kind of, the whole issue of the graph would not work well. So that's what I wanted to mention. Now, what did we do? I just want to quickly tell you at least our strategy. So I just want to explain to you a little bit about strategy. So what we have is all kinds of different graphs, and we have labels for each of the graph. That ransomware graph, a random graph, we know, assuming we know the ground truth, which is obtained, and then we run number of different algorithms, classification algorithms. Why are we running different algorithms? Because different algorithms will do better on certain subsets of the graph. So each of the classifier might find certain things better, certain kind of graphs better than others, certain kind of actors better than others. And so consequently, we ran a number of graphs, and then ultimately we had got all the results here. And then what we did was what is known as stacking. So what the stacking does is, stacking is the way to combine different algorithms. where you now run a meta algorithm on top of algorithm to be able to combine it. So that's one part which is called stacking model here. Now, once you have this stacking model, then as I mentioned to you, that we had different kind of graph, ego simple graph, ego 1, ego 2, ego 3, which is a 1-step, 2-step, and 3-step graphs. And they were simple, meaning remove all the loops and multiple edges and so on. And so this is sort of slightly different. For each of them, we got stacking results, but then they're all different data sets. So how do we combine the results across different data sets? So this is where a notion of bagging comes in. And bagging is used mainly to reduce the variance. And it does seem to do very, very well in machine learning community. So we basically started with stacking, and then we started on top of it. Once you got stacking for each of the type of the graph, we basically did the bagging of this graph. And if it turns out that if this data set, this is commonly used in bootstrapping, bagging, but I've never seen such applications being used here in this context. So just, so this was another novelty in all of this. I won't go into the details here. And I think I just want to quickly get to the results here. Once we did this, then ultimately for the, we actually got very high accuracy for separating out these 3 sets of people, ransomware, random, and gambler. And on test data sets, roughly our accuracy is around 85%. So with that, I know I want to give 5 minutes or so of time for anybody to ask any questions. So I'm going to sort of stop here, but I'll be happy to answer questions. Maybe I'm going too fast, but it has been rather challenging in some fashion. Go ahead. So if you have any questions, I'll be happy to answer. If you want, I'll be happy to talk more individually if anybody is interested.
Wonderful. Thank you so much, Sid. That was just an immense amount of really useful information. So yeah, would you like me to call on people, or Sid, do you just want to call on people directly if they raise their hand in the, let's see, do we have any questions?
Yeah, this is Yuri again. Sid, did you find any bad actors, and were you able to curtail their activity? And therefore, are you afraid of they might go after you?
I think I've not considered that possibility.
Okay.
I think so far I'm assuming that I'm safe. Academic research, and I'm assuming that, but certainly the algorithms are very valuable, and the amount of empirical knowledge and other things are very valuable. And this has become billions of dollars business right now. So there are a number of companies whose full-time work is on this kind of thing. Chain analysis, and there are a number of such companies who are actually doing this kind of thing. There are actually big opportunities in this kind of space also. Actually, if one wants to, one could actually make a big commercial success as a part of it.
So you mean this forensic tracking could be a big business?
Yes, it is. And it is right now also.
Thank you.
And this is also true in banking also. Banks are also interested with KYC and everything else. Banks have a lot of penalty if their transactions are suspicious and they do not report. And some of the banks have been charged hundreds of millions of dollars. So there is also, even in a standard banking circle, looking at the graphs and graphs of transactions is a big deal.
Thanks.
Can I ask another question?
Sure.
Did you use, excuse me, time in less increments than a day to do the association? And whether or not you change the time, might it just be something that the enemy can make use of later with longer transactions?
So you have a point. Remember one thing, they're not afraid of me. They're afraid of somebody like FBI or others tracking them. So they want to change money as soon as they can. They want to move from one account to another account as soon as possible. So usually once they get ransomware money, they want to get the damn thing out quickly. So chances are that it would not be much longer than 2 days. It could be maybe 4 days. I think we tried with number of such kind of filters, and we saw roughly within 1 day people. So as soon as the address was identified, within 1 day to most of the money was transferred. So that's what is empirical evidence. Now you may be right that people may want to change the time depending upon that. But remember, if they keep the money there, there is a chance that somebody might be able to track them down further. So they're not trying to fool me. They're trying to fool law enforcement agencies of various types. So as soon as JD or as soon as this power line company informs FBI that, oh, we have paid $11 million for worth of Bitcoin to this particular address, then you're sure to see that FBI is looking at the data in terms of blockade, because all that data is publicly available. So they'll be able to at least track down where the money went and where the money went and where the money went again. So that's why they come with CoinJoin and tumblers and everything else and change of address. So this is the sort of, my feeling is that it can be much longer. Now, I don't know how long is long. I can't tell you that. Sorry about that. Does that make sense?
Well, thank you for your answer. But on the shorter time constants, could you use those to associate an actor with the block address?
So now, if we go too short, then what would happen? So, here is the balance we had to strike, to be honest. If we go too short, then they may not, many of addresses will not be revealed. Because now you're going, suppose, for example, you just go in 10 minutes time. Then in 10 minutes time, there is only one block has passed. If there's only one block has passed, they probably have only two change addresses or 3 change addresses. But they are doing much more sophisticated than that to obfuscate their transactions. So consequently, there is this balance which one has to think about, that you don't want to go too short, nor do you want to go too long. And so I haven't tried less than, to be honest, I haven't tried less than plus or minus 1 day. It may be, you might be right, but I haven't tried it. We did try more than 1 day, but we never tried less than 1 day. But you see the trade-offs. Am I right? Is that clear at least?
Yes, thank you.
I'd like to ask a very basic question. So I'm a little bit worried I'll embarrass myself because the question is so basic, but I feel like I've asked this question to everyone I know who I think would know the answer, and no one knows the answer. So on behalf of all of us, what is the point of Bitcoin for anyone that's not a malicious actor? Does Bitcoin have any use to good people, or is it just useful to people who want to game the system like this?
No, I think there is a lot of use for it, to be honest.
Okay.
First of all, it is inflation proof because you got at most 21 million Bitcoin, correct? So you don't have to worry about suddenly Federal Reserve putting in another $1 trillion, $2 trillion of infrastructure plan and 6% inflation or 80%, whatever it is. I'm not trying to tell you no. The other one is that I want my privacy. I don't want anybody to know what money I have. So there are various basic factors. And third one is that I need to make sure that it will not collapse. So now this is worldwide, going across variety of places. Consequently, probability of its falling apart is almost close to zero. It's not going to be a banana republic of some sort. It's going to be, your money is going to be safer than possibly in dollars. This is what people's belief are. I'm not trying to tell you. I still prefer to get my salary in dollars. I don't want to try to tell you that whether if Colombia would allow me to take Bitcoin in my salary in Bitcoin, I don't know I'll take it or not. But I just want to tell you that there are people who would take things in Bitcoin. They won't take in other things. So there is a lot of concern about privacy and Big Brother watching all of us. So I'm not necessarily included in it, but I'm just telling you that there are enough number of people of that type who have it. And now, of course, there is a lot of profit motive also, because people have made so much money that it's just amazing in terms of billionaires. Number of billionaires have gone up a lot, including Elon Musk probably has made a lot of money in Bitcoin also. Does it answer your question or not? I don't know, but
No, that definitely answers it. That was just the greatest answer ever. That was just thank you. That was wonderful. Now I have a much better understanding of it. Yeah, I mean, the last part of it being a profit motive, to me, that seems like a little scary. That, you know, it's just giving a chance for the rich to get richer. And so, like, from a governmental point of view, I think that would be a counter motive. But all the other issues you brought up seem like really legitimate reasons why it's important.
and you cannot, nobody can censor my transaction. Remember one more thing. If I decide to pay Jackie Yu certain amount of Bitcoin after 6 blocks, no, you own it. There is no way a bank can come and say to another bank, oh, give me my money back because I want this thing was illegal transaction. I can't, nobody can stop it. It can't be, it's censor proof. It's immutable. Nobody can ever take back, except this example which David mentioned about, Mordecai mentioned about Ethereum and DAO. And there are lots of issues related to that.
So Sid, two things I might ask you to comment on.
Go ahead.
One is the risk that a coding error causes property rights to evaporate, and what that could do to the economy if all of a sudden asset rights, property rights that were recorded on the chain ended up, due to a coding error, just either getting corrupted, falling apart, disappearing. Because we've had some situations already where the coding errors have resulted in things just kind of not. The other one is, it's been referred to as long as the consensus algorithm eats up the kind of energy it does and produces the kind of carbon it does from the compute and the heat from the compute, that it's effectively a wealth transfer from the environment to the pockets of a few, basically the miners.
So,
You want to comment on either of those?
yeah, no, I'll comment on both, as long as Jackie allows me.
Yes, go ahead.
Let's close this thing, then I'm okay. And then we can talk. But quickly, first one, that usually it won't occur in Bitcoin, the property right and so on. Those are part of smart contracts. And a smart contract can have a bug. This is a big deal. And that's where you really have to be very, very careful on Ethereum platform and other places. But remember, all the code is visible, correct? I mean, on blockchain, as soon as you put a smart contract, everybody who wants to see can see the whole smart contract. You can copy, you can analyze, you can test, and everything else. So there is a big opportunity, commercial opportunity, for really creating testing services of various types, which would guarantee there is no certification right now available. Okay, so I just want to tell you that if you want to make money, here are the things which I can tell you. So there is no certification thing right now. There is a chance that a given contract may have a bug. Okay, people do test, and I don't know whether you know my past or not. I invented this whole method called combinatorial design testing, which has been used all over the world now. This is something I started at Balcor, and so I know a lot about all of this. So I want to tell you that this is a big opportunity. So the standard rule of thumb is that unless a lot of people are, I mean, that's what happened in this Ethereum example, which you mentioned about DAO, that there was a bug, and that bug was exploited to take away almost $300 million worth of ether kind of thing. That's what happened. So one has to be extraordinarily careful about all of this. And people are having special kind of testing agencies and other kind of things, which we are doing it, but there is no certification available. So this is a challenge. I don't want to try to discard that challenge. So, but the code is available and you can see it and you can do everything you want. If you want to do unit testing, you want to do system testing, all of that. So that's perfectly fine. The second question which you asked me was a power energy thing. So there are different kind of situations which are going to arise. This is called proof of work. So what we are doing in Bitcoin and Ethereum are what is known as proof of work. So we have a puzzle. And to solve that puzzle, there are millions of computers are chugging along trying to solve this puzzle every 15 seconds for Ethereum and every 10 minutes for Bitcoin. Okay, so but that is being changing now. For example, in 2022, Ethereum is coming up with a proof of stake kind of thing, where if you want to be mining, you have to be ready to burn away certain amount of ether. Then only you can win. But your probability of winning a mining right depends upon how much are you ready to give away as your ether and burn it off, which means nobody gets it. That means it reduces the amount of ether which is available in the market. So that's what is happening. Bitcoin hasn't done it yet, but we'll see what happens. I don't know whether that answers your question or not.
Well, I appreciate it. I was aware of that. I don't think it solves the excess compute for no good reason problem. And the amount of carbon produced and heat, waste heat produced. I understand some of the mining clusters now are being put in the Arctic, which to me just accelerates.
So, you know, David, we can have an argument about this, and I am not necessarily. I'm sympathetic. Listen, I believe in sustainability and everything else. But remember, 10% of everything we do with financial companies today, everything we do today, around 5 to 10% of money is being taken away by banks and broker. I mean, you name it, all of those people, okay, who are exchanging one currency against other currency, foreign trade brokers, and so on and so forth. How much is the energy which is being used by that sector, and how does it compare with what this sector is using? Have you ever thought about that? How much?
That is clearly something that needs to also be considered.
Yeah.
No, I agree with you. That's something that has to be put into the equation as well.
Yeah,
It's an interesting thought.
Nobody has done it so far.
Yeah.
Think about it, that all these people who are arguing, some of them are banks and exchanges and everybody else who have got big stake because they want to retain those customers. Listen, I'm not going to argue with you about other things. I don't want to try to tell you.
No, I just wanted to know what your thoughts were, and that's very helpful. Thanks.
Okay.
So I'm just curious, you mentioned that you invented this combinator design testing process. Is that like, so why combinator? Does that come from that?
It's very interesting. Yeah, it is based on combinatorics. So the idea is very, very simple. So if you ever want to know, there are several papers, and it's being now used all over the world. The patent has expired. Everything else is gone. Everybody is welcome to use. IBM is a big service in this area, and a number of other people have these big services in this area. And that was invented by 4 of us at Balcor. So just to let you know, and the basic system was called Automatic Efficient Test Generator System, AETG. But now there are so many variations of this, and number of papers which have appeared are huge, and people are still. But it's all based on combinatorics. And
so there's another question from Jeff Weil. It says, could you address CoinJoin in the context of the heuristics? Wouldn't CoinJoin defeat your algorithm?
Yes, it does have a chance of defeating our algorithm. So what we do, and I think this is described in the paper. See, first of all, we have to tag a transaction, CoinJoin transaction. So we have an algorithm to try to tag it. Okay, if it is a CoinJoin transaction, then we don't put them in cluster, but we keep them separate, so that we are not able to associate with them. So we don't put them in clusters. We deal with them separately. And remember that ours is always local clustering. So it's not a global clustering where we get defeated very badly. Even if we make a mistake in 1 or 2 or 3 or 5 or 8 of graphs, they're only local. So they're not likely to geometrically explode. I don't know whether that's a good enough answer or not, but we did a lot of experiments related to CoinJoin, which actually took almost 3 to 4 months of work in terms of kind of experiments which we could do to find CoinJoin. And there have been, clearly there are challenges. I'm not going to disagree with that. I don't know whether that's the satisfactory answer or not. I don't know. It's a factual answer.
Well, hopefully Jeff will pick that up. Sid, the other question is, what's your opinion about a currency whose value fluctuates, where not only are you using it to trade, but you're gambling on its value?
So, okay, I think we're going to philosophy, which I don't know how to answer. But What do you think? Let me put that way. What does the audience think? Actually, I would love to hear from you guys. What do you think of?
I'll wait for others.
I guess, can I ask a clarification to that question? Couldn't you ask the same question for any currency, or is there something specific about that question for Bitcoin?
It's more specific for Bitcoin, I would say.
But with any currency, you're trading and then gambling on the value of the money, right? So why is that? Why is it more specific to Bitcoin? Does
Yeah,
the
but-
Bitcoin does the Bitcoin value fluctuate
yeah,
more?
the
volatile?
difference-
Yeah.
The difference is every other currency or asset has an intrinsic value that's tied to some productive capacity of an economy and
Thanks, Tom.
Navy and an air, or some physical use. And this is not tied to anything like that. And it's nobody's liability. So there's no central bank, there's no ultimate agent. It's just the intrinsic value is zero. So,
Okay.
yeah.
Thank you.
Anybody wants to answer? Otherwise, I'll put my big mouth and I try to answer. But I would rather hear from you all. Anybody else wants to answer? It looks like almost my class. I have to prod people to answer. So can I ask prod somebody to answer?
Hey, it's Khan Osbeon.
Sorry,
I'm
go ahead.
here, and I know nothing about this, so I'm just listening. But I mean, the one question I had completely not related to the comment of Sid. Hi, Sid, how are you? You talked about privacy, and like as one of the 3 points. But I don't know who needs that privacy that you're talking about. I mean, why would you need any? I mean, we don't have any privacy. I mean, when you want to buy a house, they see everything in terms of your income. I mean, like all your history. So, I mean, who are these people who need this kind of privacy that nobody has to know anything about their wealth? I don't understand that.
I think
Yeah, I agree. I don't understand that either.
I think either you might be cynic because everybody can observe what I do. Google knows what I do every day. That's what you're saying. But we need,
No, not that. I mean, I'm just like, you buy an apartment. I mean, they not only look at you, like how much money you're making, how much money you have in the bank, how much tax you paid. They look at your kid's car, your wife's job, I mean, everything. So, and we cannot say I need privacy. So who are these people? I mean, who don't even want to talk about the money in the bank? I don't know.
Khan, the people who are doing that create a private company. Give you an example. In the town where I live, people are buying homes, and then the homes being the address the address to which any legal documents need to be sent is a lawyer. So it's people with a fair amount of money who are trying to manage their assets. I mean, the price of property in London and New York shot up. I mean, London's supposed to be an outpost of Russia in that regard, almost.
Mm-hmm.
So it's really, by and large, it's the wealthy people. But at the same time, I agree with Sid that whatever we can do to prevent our privacy being abrogated as much as we can, we should.
But it's not possible. I mean, given the legal system in this country, I mean, only possible for some people who can hide this stuff. I mean, for regular people, which is 99.9% of the people I'm talking about, is it worth the the mess that is creating? I don't know.
Mm-hmm.
I mean, I'm not so certain, because overwhelming majority of the people, this has no impact, because you cannot operate in this society. It's not a question of you have money or not. You cannot operate in this society if you want to hide everything that you have. I mean, that's how it is. I mean, there's something called credit reports. I mean, they just want to know if you paid your credit cards on time. So within the league, I mean, this is, to me, it's like, Sid did not mention about this. This is basically to be able to move money around without anybody knowing. I think that's the only I mean, other than just like the fun of playing and making it's like gambling. Just you want to be able to move money around without the nation state telling you what to do.
I think I'll find a lot of counter examples. So, but those are all, what I would call as more of anecdotal. But like, for example, a woman who wants to go and have an abortion, a person who wants to pay his mistress or her somebody else. There are a lot of places where you don't want people to know. I mean,
you could go to the Soviet Union or Belarus where you want to be able to send value. I'll give an example right now. If you want to send money to Belarus or any value, it's completely intercepted by the agency, by the various agencies. But, so if you want to support, for example, and I'm not saying one or the other, but if you believe that providing support to individuals in Belarus to support, quote, democracy, then Bitcoin might be a good way to do that.
Yeah, that's where the Tor was invented. I don't know whether you two know the history of Tor, but Tor was invented, which is nothing but one which it's very hard to track anybody on that. It's dark web. But part of it was invented originally was to support people who were dissidents in states which were controlling states, and people to be able to express their opinion was not feasible unless they went through Tor.
I mean, yeah, but this is, look, I mean, your dissidents are my terrorists. So, I mean, just let's not go into that.
Oh, God. No.
Right? So,
You want.
I mean, I think, but I mean, let's talk about the normal society like US. Except like a very, very small number of people, I think this has no value. I have to tell you that as money, because we cannot, again, it has no value because we cannot operate in this society if you keep your money like this.
I think the technology is
Jason, you're breaking up, mate. And you've gone.
Maybe it was a very controversial point.
Sorry, can you hear me now?
Yeah.
All right, sorry. So I think you have to look at it as the blockchain technology, right? With Bitcoin, I completely agree. The fluctuations in the currency, like I would not feel comfortable using it as a digital asset. Right. That being said, though, they have digital assets that are tied to the US dollar as well. And so I see this as the opportunity to make the financial systems more accessible to others that wouldn't necessarily have that, right? The good use cases are in developing countries where you have towns that don't have access to the typical financial institutions. This could be an alternate mechanism for that distribution. Privacy aside, because I agree it's definitely used for more malicious purposes right now than good, but that's, I think, the beauty of what blockchain presents is it allows the addition and kind of growth of these technologies for what really fits society as a whole, depending on whatever the use cases are. There'll always be bad cryptocurrencies, but I think we'll see the evolution of ones that actually will get adopted and be grounded in something more stable than just what speculators are saying the cryptocurrency is going to be valued at today.
We'll all live in meta. Holy shit.
Yeah, that's terrifying.
Yeah, here's another interesting aspect about these cryptocurrencies. Some of them, for example, Bitcoin, which varies a lot and therefore is more like, it's a risk. They've been declared as haram by various Islamic countries because that is to be, say, forbidden because it's gambling. It's interesting how the behavior of these currencies are interpreted in different ways. And there's just no doubt in my mind that we're going to see these digital currencies evolve. And as Sid says, the friction induced by people and companies and banks and others with their hands out trying to get a piece of the action might get reduced. But of course, these people have been figuring out how to take a piece of the action all their days. So I'm sure they'll just find another way to do that. Sid, what do you think? Do you think this friction of movement will be reduced and there'll be more value given to the people who own the currency?
You know, it's very interesting. Sorry, I can't answer your question well, but
Yeah.
I'll tell you one thing, that right now, if you look at Bitcoin and so on, a lot of the price changes have nothing to do with common people. It has
Yeah.
nothing to do with all these institutions who are
Yeah.
themselves investing. So remember that now. Now
You're right.
JP Morgan is investing, Morgan Stanley is investing, Goldman Sachs is creating Bitcoin thing. So remember, it's not anymore if you think, oh, well, who needs it? All of these are investing. This is one other class of investment, just like commodity. People might buy corn, people might buy uh, something else. This is just another. So if you want to think about it, this is nothing but another. If you want to think about it, this is
Yeah.
another asset class where people would invest for a variety of reasons, including how uncorrelated is it with some other things in some fashion. So this really comes out from financial portfolio perspective. What do you want to think about it? So currently, a lot of things which are happening are not necessarily common people, the one
Right.
we talk about. So I just to let you know that
Yeah.
right. Listen,
No,
I'm not trying to sell you Bitcoin, so please don't take it wrongly.
no, I know.
Nothing to do
I suggest that CUSP create a CUSP coin that we can make some money out of. Jackie,
Yeah.
that's for you.
Yeah, okay. No, but I do want to say that I really, even though I started feeling very cynical in the beginning, I do have to say that some of the examples being brought up, such as, I think that from an American perspective, it doesn't feel like there's much of a point. But if I'm coming from a country where the government is really limiting my
Yeah.
freedom, then having a way to make transactions anonymously is incredibly liberating. So now I'm
Yeah.
kind of, I've switched teams here. So,
Good.
but I do still worry about the malicious side of it. Like, well, it's obviously the whole point of this talk, but also, it seems also like, yeah, in terms of like investing, and it's like, you know, if you're investing something in something that like inherently doesn't have any value, then is it helping the economy as a whole, or is it just helping rich people get richer? I guess that's always my like skepticism of any investment, is like, what is it doing holistically to the society? But that's a really complicated question. And again, I'm coming from a really naive perspective with it. But yeah, it's that way. It's just, this is fascinating.
I'd like to ask a fundamental question, which is how does someone that's already in the system exit the system, and does he get other value when he exits somehow?
So hold on. So let me try to answer. Let me try to understand. Let me not say that I'm going to answer. What do you mean that if I'm in system, meaning I own some asset, Ether or Bitcoin or DAI or any of those things, then how do I exit? Is that what your question is? Then
Yes.
that's because
Yes.
you can sell it off to somebody else and they'll give you dollars or whatever currency you want. Mark, you want.
I just want to say I will be right back. I'm going to keep the meeting running, but I just have to run upstairs for 1 second. So keep on talking. I'll be right back. Okay.
Yeah. So so that's easy. There are lots of places where you can sell and you can buy anything else. There are so many now exchanges, compounds and others. You can exchange between currencies also. So you can buy from Zcash to Ether to, you can buy then to Bitcoin to Dogecoin and all Dogecoin and all of those things. You can do it. It's trivial. It's not a big deal.
Well, that answers my question.
There are a lot of such kind of things are opening. This is where the money is, because this is where people are finding that how
So how do you pay tax on that? I mean, so nobody knows when you bought it, but they know when you sold it. So how do they tax you on that?
Okay, so are you talking about legal things or are you talking about something more than that?
No. I mean, you know, when I sell my stocks, I mean, they know that I paid $1 and I sold it for $2, so I pay capital gains. No, so here, how does the government know when I bought it?
If I am part of America and if I buy things from American companies operating on American soil, then there may be KYC requirement, and they would have to report it. But if I am now dealing with, let's say, from somewhere Gibraltar, where there are lots of cryptocurrency companies, then in that particular case, it's your responsibility to report it. If you don't report, it's just like your Swiss bank account. That if you don't report, then government may someday find out, then you might be penalized. But that's up to you.
Yeah, but I mean, so if the government, if I'm an honest citizen, if the government knows when I bought it and when I sold it, let's say in the US, so there's no privacy. So that means it's very likely that
No, but
I will sell it somewhere else. No, I mean, I want to sell it in Gibraltar, as you said, so.
remember that when you do, nobody knows where you got the money from or where you gave the money. That's a different story. You're just talking about exiting or entering.
Yeah, but how do I report that? I mean, how does the government make sure that that's reported?
Well, I mean, okay.
I mean, if there's a mechanism, then there's no privacy. If there's no mechanism, then there's a huge loophole.
Well, I mean, but it's like cash business. Any cash business, people, it's up to you as a shop owner to report it or not. It's not clear to me that all the shops in New York City reports every penny they earn in revenues or not. I just don't know that.
Yeah,
I mean,
but New York City shop owner works very hard to make that money. This is just sitting on, I mean, this is just taking risk, but not more than that.
Well, but still, anyway, I listen.
Yeah. I mean, you're not selling Bitcoin. I understand it. I'm trying to understand. I mean, either there's privacy or there's no privacy. You're saying that if you decide, nobody has to know how much money you made, basically.
Or whom I paid, whom I didn't pay. That's none of anybody's business as a part of all of this, which is already available elsewhere.
Okay.
Well, I don't know. Are we trying to create another bank, which is already taking 10% of your asset every time you do any
No,
transaction?
but it's not, I mean, it's not only about me. I mean, the way we pay tax, it's not only because the government comes and collects the tax from me. It's also because I vote for politicians who will tax me so that society can benefit from it. So if it's all about me, I would only vote for politicians. They will never tax me. Okay. So I mean, there's also social. I mean, because I want to live in a society that's fair and safe and all that, and I understand that I have to pay for it. So I mean, I mean, the tax question is not that trivial, if I may say.
I agree with you. I don't disagree with you. Sorry, I just don't.
Yeah. I mean, of course, I don't want to. I mean, and then the financial institutions, I agree with you. I mean, they, they take our money, but that's. I mean, I'm not an expert on that, so I don't know how much I'm paying for my retirement account. Maybe just too much. Maybe I should put everything in Bitcoin.
I wouldn't do it, but anyway, it's up to you. How much % you want asset class? Anyway.
Hey, Sid, another question. You mentioned the exits, that there were many exits. Can you use the exit paths that you identify happening to help correlate the bad actors with the subgraphs you've built elsewhere?
That's the next challenge, to be honest. So this is really an emerging area. See, there are so many things like what you just mentioned, that there are so many now DeFi. There is this whole world called DeFi, which is nothing decentralized financial thing. And there are hundreds of such companies which are being created now. And there are lots of challenges here. How do you look at all of these are public, correct? I mean, all the transactions are viewable. Everybody can view it. Now, so there is a tremendous amount of opportunity to create companies which would automatically able to look at this kind of transactions across and do something with it. So
the exits are witnessable, but the anonymity is still there.
Yeah, anonymity could be there, but there are various ways, just like what we did now, is slowly breaking up a little bit about anonymity, not a lot, but it does. So there are challenges. But that's why there is a lot of opportunity. Commercial opportunity exists. A lot of commercial opportunity exists. I really would like to think about that. Think about the commercial opportunities in starting new things as a part of it, including new dApp new DeFi protocols and everything else. And the people are wanted. Listen, at the same time, I'm not expert on all of this. I am a simple machine learning guy who thinks about all of this and does something. And
I'm just wondering if the exits would help narrow some of the search when looking for the bad actors.
there is a good chance. There is a very good chance, because I would convert from Bitcoin to Ether and Ether to Zcash and Zcash to somewhere else. You have a point. There is a lot of stuff which can be happening. But while you're within that network, you can track it down. Across network, then you'll have to go and look at the network which are transforming it. And you'll have to look at that. So there is a lot of opportunity here, to be honest.
Especially if the exits are repeatable.
Yeah, most of them are. Because everything is viewable. So I think I have anything else, otherwise I'm going to stop now. I do have another meeting in another 7 minutes. So if you want, I'll be happy to be around for 7 minutes, or I can we can talk some other time, or I'll be happy to come and visit you guys. Anything anybody wants to say? I think Jackie seems to have.
Jeff Wiley might have a question.
Okay, Jack Wiley, please go ahead. Jeff, you have a question? Jeff Wiley is saying that his microphone is not working and he'll follow up with me. Thank you so much. Then I'm going to now say bye and have a great weekend. Is that okay?
Thank you.
Thank you.
Thank you so much for inviting me, and I really appreciate it. Take care and have a good day.